let's start with the edge-triggered flip-flops. As per the definition or the basic definition, what flip-flops are? Flip-flops are basically the latches with the clock elements. They are the circuit whose output changes not with the change in the input, but the output changes with the change in the clock pulses. The flip-flops can be synchronous bistable devices. They can be of different types. That is, the output of the flip-flops can be changed or they can vary depending on the type of the clock pulses. As studied before, the clock pulses can be again of two types: positive edge triggered or rising edge, which can be seen here. This red, the edge with the red are called as positive edge. That is, when the clock changes from 0 to 1, we call it as a positive edge. Similarly, when the clock changes from 1 to 0, you can see with the blue color line 1 to 0, 1 to 0, or high to low, they are called as negative edges. Therefore, the flip-flops can work as per the positive edges or as per the negative edges. That is, they change the state either at the positive edges or they change the state as per or as the negative edges. These are the different kinds of triggering flip-flops: SR flip-flops, D flip-flop, JK flip-flops, and edge-triggered flip-flops. Now, the positive edge-triggered flip-flops are shown directly by the greater sign, which we can see here. That is, this clock pulses, clock pulses, clock pulses. Therefore, all the above are positive edge triggered flip-flop. Either this is SR flip-flop, D flip-flop, JK flip-flop. Similarly, negative edge triggered flip-flops are those flip-flops which respond to the negative changes in the clock. That is, the output varies when the clock pulses changes from 1 to 0. The symbol for the negative edge triggered flip-flop can be shown as follows: greater sign with the bubble. This bubble indicates that the flip-flop here is a negative edge triggered flip-flop. The first kind of flip-flop is SR flip-flop. SR flip-flop again can have different types of mechanism. One may be positive edge triggered flip-flop, that is the output changing when the clock changes from 0 to 1, and the other will be negative edge triggered flip-flop, that is the output changing when the clock changes from 1 to 0. The SR flip-flop on the triggering edge of the clock pulses are called as edge triggered flip-flop, depending whether they are positive or negative. When S is equal to high and R is equal to low, that is, when S equal to 1 and R equal to 0, the output of the flip-flop is 1, that is, we get it as a set state. Similarly, when R is equal to high and S equal to low, we get the output as 0, which is a restate state. When both the inputs are low, the output given is the previous output, that is, we call it as a hold state or no change state. And when both the inputs are high, which is an invalid state, as we have seen before. Therefore, the characteristic table of the positive edge triggered flip-flop can be as follows: 0 0 QT, which is no change; 0 1, which is 0 or reset state; 1 0, which is 1 or set state; and 1 1, which is an invalid state. Now let's see the part of flip-flops, what all applications can be done with the SR flip-flop. SR flip-flop comprises of three parts: a basic NAND latch, a pulse steering circuit, a pulse transition detector or the edge detector circuit. Now the pulse steering circuit can be considered as a clock. What we see, that is a pulses. The pulse transition detector again is a very important part of the SR flip-flop. Now, how can the circuit understand whether the clock or whether the output for which it has to change should be on the rising edge or on the falling edge. So for this reason we have a pulse transition detector or the edge detector circuit. The pulse transition detector circuit is that detector that detects a rising or falling edge and produces a very short duration spike. That is, the pulse transition detector circuit helps the flip-flop to change the output on the rising edge or on the falling edge depending on the type of circuit what it is designed for. Well, the SR flip-flop using NAND latch, we can say this, the pulse transition detector as seen the pulse transition detector, the pulse steering circuit or the clock which can be seen here, and the basic NAND latch what we have studied. This is the basic NAND latch. Okay. This circuit, the middle circuit, is a pulse detection circuit which shows whether the output should raise or whether the output should vary for the rising edge or should for the falling edge. Similarly, we can see for the positive going transition rising edge, this is a clock, that is, the clock for the rising edge directly goes into the NAND gate, and when the clock should have a falling edge, it is passed through an inverter. That is what we can see from here. That is, suppose this is a clock going on, then its complement can be a falling edge, and the clock transition, that is the difference between the rising and falling edge, is shown in this part. That's this transition or this difference is for positive going transition or the rising edge. Now similarly, let's take for the negative going transition or the falling edge. Now for the falling edge, we take the bubbled NAND gate. The operation of bubbled NAND gate is very much similar to the operation of the NOR gate, and before passing on to the bubbled AND gate is very much similar to the NOR gate, and before the clock is passed through the NOR gate, one input of the bubbled NAND gate is given through a NOR gate which is passed through clock, and the other is directly passed through the bubbled AND gate. So we can check out when the clock is high, after certain transition or after certain duration, the clock bar, it goes low, and the difference between the clock going low and the clock bar going high is called as a transition time, which is given by clock star, and the above is for negative going transition or falling edge. So before going on to, let's check out the characteristic table for SR flip-flop, or how the SR flip-flop can work on. Let's check out the working of the SR flip-flop. Now the SR flip-flop truth table is S. First of all, we have to find out the characteristic table and characteristic equation for SR flip-flop. Characteristic table for SR flip. Let's say SR, two inputs are 0 0 0 1 1 0 1 1. Q plus is the next output, as we say, which is Q 0 1 invalid. This is the truth table. Now the characteristic table can be found out using SR, current output, and the next state output. So we just try out with three inputs: 0 0 0 1 2 3 4 5 6 7. Okay. So we check out from this SR, this, and last is this. So let's compare this characteristic table with the truth table. When S is 0 and R is 0, the output is the whole state, that is the previous output. So in this case, the current output will be the previous output, which is 0 and 1. When 0 and 1, the output will be 0, which is the reset state. 1 0, the output will be 1, which is the set state. And when 1 1, the output will be invalid state.